Title: The Gallium Bottleneck, Weaponized Supply Chains, and Western Defenses. Flint West reporting. Pinpoint position. China's dominance of gallium is not a mining story. It is a processing story, and that distinction matters. Gallium is one of the hidden materials that quietly sits beneath modern civilization. Most people will never hear its name. Yet without it, much of our advanced military hardware simply does not exist. Fighter jet radars, missile guidance systems, high-frequency communications, and next-generation telecommunications infrastructure. Section 1. The uncomfortable reality is this. China controls approximately 98% of the world's primary gallium refining capacity. That transforms an obscure industrial byproduct into a single-point failure for Western national security. But the crisis is not geological scarcity. The West is not running out of gallium. The West is running short of processing capacity. And once you understand that distinction, the solution becomes much clearer. The objective is not to find more rocks. The objective is to reclaim industrial capability. Section 2. Contextual cloud. Start with physical reality. Gallium does not exist as an independent, mineable ore. You do not simply dig a gallium mine. Instead, gallium exists as an ultra-dilute trace element embedded inside bauxite rock at concentrations of approximately 30 to 80 parts per million. That translates to roughly 20,000 to 1 through 33,000 to 1. Think about that for a moment. Gallium is hiding in plain sight. The process begins with raw bauxite ore. That ore enters the Bayer process, where it is chemically refined into alumina. The alumina is then used in aluminum smelting, and buried inside that industrial stream is something extremely valuable: gallium. The recovery circuit branches directly from the Bayer process itself, typically recovering approximately 10 to 15% of the bound gallium present within the material stream. That means whoever refines the world's bauxite ultimately controls the world's primary gallium production. And over the past 3 decades, China played the long game: subsidized energy, aggressive state investment, massive industrial capacity building. While the West was offshoring heavy industry, Beijing was quietly building the world's midstream processing capabilities. Section 3. The result was predictable. China captured both aluminum smelting and alumina refining. And when Western refineries became economically uncompetitive and began shutting their doors, domestic gallium production disappeared alongside them. The United States has not produced primary gallium domestically since 1987. This is not a natural monopoly. It is an industrial monopoly, and industrial monopolies can be rebuilt. This content is brought to you by Bobby Giggs. Promote your brand here and reach a wide audience across platforms like YouTube, Instagram, and Facebook. Follow the links in the description to get started. Section 4. The strategic stakes are uncompromising. Beijing eventually transformed industrial dominance into geopolitical leverage through strict export controls on gallium and germanium, later suspending selected shipments to demonstrate precisely how much leverage it possessed. And suddenly, an obscure industrial metal became a strategic vulnerability. Consider what gallium actually enables. Active electronically scanned array radars rely upon gallium nitride semiconductors to operate at significantly higher temperatures and power densities than legacy silicon systems. The result is greater detection range, greater resolution, and superior battlefield performance. Gallium arsenide sits at the core of missile guidance systems and hypersonic radio frequency sensors. And perhaps most importantly, there are no direct substitutes. More than 11,000 United States military components depend upon gallium nitride and gallium arsenide compounds. At sufficiently high frequencies and power levels, alternative materials impose unacceptable performance penalties. Sometimes there simply isn't a substitute. Section 5. So what does the response look like? Building entirely new greenfield mines would require billions of dollars and potentially a decade or more of permitting and construction. That timeline is unacceptable. Instead, the West has adopted a 3-tier industrial strategy: short-term, medium-term, and long-term. The short-term objective is simple: bridge defense needs. Military demand for gallium is surprisingly modest when measured against global commercial electronics production. We are talking about single-digit to low double-digit metric tons annually. That creates an opportunity. High-purity gallium can be reclaimed from semiconductor manufacturing scrap, and Defense Production Act Title III funding can be deployed to rapidly expand advanced chemical separation capabilities. Recycling, recovery, and strategic stockpiles. The objective is not perfection. The objective is time. Section 6. The medium-term strategy is perhaps the most elegant. Do not build entirely new infrastructure if existing infrastructure can be upgraded. The fastest path toward primary supply is not necessarily construction. Sometimes it is retrofitting. A $450 million strategic partnership between the United States government and Atlantic Alumina represents precisely this approach. Backed by a $150 million preferred equity investment from the Department of Defense, alongside private capital, the partnership is retrofitting the last remaining United States alumina refinery in Gramercy, Louisiana. By inserting a countercurrent ion exchange circuit directly into the active Bayer liquor stream, the facility aims to produce up to 50 metric tons of primary gallium annually, enough to satisfy 100% of United States domestic demand, not through discovering new resources, but by rediscovering industrial competence. Section 7. Finally, we arrive at the long-term strategy. Biomining. Legacy bauxite processing leaves behind enormous quantities of alkaline waste known as red mud. And hidden inside that historical waste sits concentrated trace amounts of gallium, often ranging between 50 and 100 parts per million. Yesterday's industrial liability may become tomorrow's strategic reserve. The mechanism is fascinating. Specialized microorganisms produce organic acids capable of releasing metals bound within mineral matrices without requiring extreme heat or harsh synthetic acids. Stirred tank bioreactors offer higher throughput at higher capital costs. Heap bioleaching offers lower-cost alternatives with slower processing cycles. Neither represents an immediate solution, and neither needs to. This is a generational play. The objective is to convert decades of industrial waste into decades of strategic optionality. Section 8. The broader lesson extends far beyond gallium itself. Supply chains are not merely economic phenomena. They are geopolitical infrastructure. And geopolitical infrastructure eventually becomes national security infrastructure. The gallium bottleneck was never about running out of material. It was about forgetting that civilization is downstream of industrial capacity. China understood that. The West is beginning to remember it. Because this story was never about mining, it was always about processing. And whoever controls the processing ultimately controls the leverage. Flint West, signing off.